Hi guys, today we're going to learn about definite integrals and their properties. First, let's look at the notation. Okay, so the area between f of x above the x-axis, okay, on the interval a comma b is going to be denoted as the integral from a to b of f of x dx. What's the meaning of this expression? Well, this a is going to be what we call the lower limit, okay, and b is going to be the upper limit, okay. So please remember that your function is f of x dx, okay, so it's going to be the area in between a and b above the x-axis and the function f of x, okay. So that's the meaning of the definite integral, and they are going to look like this. The properties that we have for definite integrals are the following. If we have the integral of a to a of f of x dx, this is going to be equal to 0. If you think about the situation, you know that the base of this rectangle is 0, and that's why the area of this situation is going to be 0. Okay, now over here, comparing it to the first notation that we use, we recognize that the a and b are flipped. Therefore, to flip it again to be from a to b, we need to put a negative here at the front of f of x dx, and this is the property that we have here. Okay. Similarly, we have with functions, you have that if c is a constant, then you have that the integral from a to b of k of f of x dx, this is going to be equal to k times the integral from a to b of f of x dx. Please note that the k must be a constant. Okay. If c lies between a and b, meaning c is an element of the open interval, a and b, okay, you have that the integral from a and b of f of x dx, it can be broken into two different integrals. So the first one is going to be the integral from a to c f of x dx plus the integral from c to b, okay, f of x dx. Okay, and this, we can do this because c is an element of the interval ab and it's in between a and b. Okay. The next property that we have is this one, that it's pretty much an addition property. Okay, so this property, what we have is the integral from a to b of f of x dx plus the integral of a to b of g of x dx. Okay, as you can notice, I broke down this integral into two separate integrals, and we can do this in this situation. Okay, please note that the integral symbol always comes with the dx. That's why I have here two integrals and two dx's. Okay, similarly here we have the difference. Okay, so it's going to be the integral from a to b of f of x dx minus the integral from a to b of g of x dx. Okay, so these are the properties that we're going to be using for definite integrals. Now, before we start, I want to give you a warning. Okay, so please note that there's no so-called product property or anything like this. This is like a very sad situation and you don't want to use it. Similarly, this situation is not going to happen, so please do not try to use it. That is a monstrosity, so these are no-nos. Okay. So now that you know the warning and you know that you are never going to use that, we're going to sketch and evaluate using geometric formulas. Okay, so what are you going to do here? Here we have the integral from 1 to 6 of 4 dx. Okay, so here what we have is that, let's say that 1 is here and 6 is here. Okay, so this is your x interval. Okay, these are your x's. Okay, here you have your y's or f, however you want to call it. Okay, so you know that your function here is going to be f of x equals 4. So you know that if I plug 1, it will give you 4. Let's say that here is 4. If you are computing f of 6 in this situation, it would be 4 as well. So for this situation, we have my graph of this situation, specifically in that interval. We know that we are looking for a situation like this. So this figure, as you can see, it's a pretty user-friendly rectangle, and the base is 5 and the height of this rectangle is 4. Therefore, that integral is going to be 20. Okay? So following the same idea, over here for part B, we can say that here's 1 and here's 3. Okay? So your function here, f of x, what I think in my brain is that f of x is equal to x plus 2. So if I think about that, when I plug the 1, what happens here? You have that it's going to be, let's say that 3 is here. So that f of 1 is 3. In the same way, you can see that f of 3 is going to be 5. Okay? So let's say that 5 is over here. So you're graphing this equation. It looks like something like this. Okay? So you're going to tell me, hey, I'm not sure what's that. How can we compute this? No worries. What you can do here is you can divide it and have two figures, composite figures from geometry. Okay? So you can see a very user-friendly rectangle over here and a triangle here. The rectangle that you have over here, the base is 2 and the height of that rectangle is 3. And then the triangle that you have here, the base is going to be 2, okay, and the height is going to be 2. So as you can see, I'm finding the area of the rectangle that you see here and the triangle that you see here, and you add them together. So this integral is going to be equal to 6 plus 2, which you know that it's 8, and that's pretty much what you'll have for this problem. Okay? Now the next one that we have over here for C, what you have here is the integral from negative 2 to 2 of the square root of 4 minus x squared dx. So you can recognize here that this is a semicircle. Moreover, you can see that this is the positive, or the part that is above the x-axis of the semicircle. Let's draw it so you can see it. Okay? So if I draw my semicircle over here, and here, and then we have a situation over here. So that's going to be 2, negative 2, 2. Okay, so we have a semicircle that looks something like this. Okay, so we're looking for this area, the one that it's above the x-axis. How can we find that? Well, you know that the area of a circle is pi r squared, but here we only want half, so it's going to be half pi r here is 2 squared, so you know that this is going to be equal to 2 pi. Okay, so now I want you to note that these 3 examples we have that our areas are positive. Why these areas are positive? Because in all these situations, pretty much what we have is some figure above the x-axis. Okay? In the following example, part D, you can recognize that this little area over here, that's a pretty user-friendly triangle. But the problem that we have here is that one is below the x-axis. And you can recognize that this is the integral from negative 4 to 4. So here, okay, that's my negative 4, and my 4 is going to be over here. So you can see that this is going to be an area that it's negative. Okay, so that's going to be negative 1/2, and the base of this triangle is 3, and the height is 2. Okay, here you follow with the next triangle that you can see over there, and that's going to be positive because that's above the x-axis. And this is going to be the base is 3 and the height is 3. Then we have another little piece of triangle here, very small, which is going to be negative. So it's going to be negative 1/2, and the base is 2 and the height is 1. So you have that this is going to be equal to, what's that going to be equal? Negative 3 plus 9/2 minus 1. Okay, when you combine this, you recognize that this integral is equal to 1/2. Meaning that the area that it's above the x-axis is bigger than the two pieces that are below the x-axis, and that's why it's positive. So in these situations, you could have an area that it's negative, and that means that the area that it's below the x-axis is bigger than the one that you see above the x-axis. Now we're going to use the properties of definite integrals. we have that the integral from 0 to 3 of f of x dx is equal to 4, and the integral from 3 to 7 f of x dx is equal to -1. They want you to find the integral from 0 to 7 of f of x dx. So the first thing that I recognize is the 3 is between 0 and 7. Therefore, I can pretty much put together these two integrals to find this equation. So you know that the integral from 0 to 3 of f of x dx plus the integral of 3 to 7 f of x dx is going to be equal to the integral from 0 to 7 of f of x dx. Moreover, you recognize that I already know the value from the hypothesis of this equation. You know that that is going to be 4, and this equation is going to be -1. You combine these two, and you have that that integral is going to be 3, and that's pretty much it. Similarly, here we are going to use more properties. Okay, so you recognize that 2 is a constant, and we have the integral from 3 to 7 of 2 times f of x dx. So the first thing that I do, I take the 2 out because that's a constant, and we can do that with the constants. That's the beauty of the constants. So I have this equation. I recognize that I have this here. Okay, so this is going to be equal to 2 times -1, which you know that it's going to be equal to -2. And that's pretty much it. Now the last problem that we have over here, we mentioned that the integral from a number to the same number, f of x dx, this is going to be 0 because the base of your rectangle is going to be 0. And that's pretty much it. I hope that you find this video helpful. Bye!